Did the universe have a beginning? If it did have a beginning, how did it happen?
Why is the universe as bizarre as it seems to be?
Will the universe have an end? Will it have a death?
Why is the universe so apparently complex? Why is it so rich? Why isn't it simpler?
Cosmologists are coming up with some of those answers today.
We've learned more about the universe in the last few decades than in the rest of human civilization put together.
One thing we do know today is that our universe is getting bigger.
If we look at our universe today, we find that it's expanding. The galaxies that are a long way away from our galaxy are moving away from us.
This discovery was made in the 1920s by the astronomer Edwin Hubble with the biggest telescope of his day.
He pointed that telescope at distant galaxies. For the first time, we could see those distant galaxies. And he noticed something very funny about the light from them. The light from those galaxies was redshifted. That meant those galaxies were moving away from us. If you stand at the side of the road and you hear an ambulance drive past, you'll hear the siren on the ambulance as a high-pitched sound, and then the ambulance will drive past and the pitch of the siren will go low. The reason the pitch of the sound is changing is not because the siren's note is changing, it's because the ambulance is moving relative to us. There's a similar process for light, only this time it doesn't affect the noise, because light doesn't make a noise, it affects the colour of the light.
Like sound, light travels out from its source as a wave. Different colours of light have different wavelengths. Blue light has a relatively short wavelength, while red light has a relatively long wavelength. If an object is moving away from you, then the wavelength of the light is stretched. It moves towards the red end of the spectrum, and so we call this redshift. Every galaxy Hubble looked at was rushing away from ours.
He realised that the further away the galaxy was, the bigger the redshift of the light. That meant those galaxies were moving away from us at faster and faster speeds. It's not that the galaxies are moving apart, it's the fact that the entire universe is expanding. The whole of space is getting bigger.
Turned on its head, and this discovery leads us to an astonishing conclusion.
If something's bigger today than it was yesterday, then yesterday it was smaller than it is today.
Just trying to run the movie backwards, you have to conclude, it's not rocket science, that all the matter that we see today must at one time have been in a very dense and hot region of space. And that is the phase that we call the Big Bang.
We've now more direct evidence that our universe started with the Big Bang.
If we can look in the right way at the universe, we should be able to see the afterglow from the Big Bang, the heat left over from the Big Bang.
Astronomers were looking for the smoke left after the fireworks, and sure enough, when they looked, they found it. This is a picture of the heat left over from the Big Bang. It is a picture of our early universe, and like a fossil record, it also gives us clues to how our universe evolved.
This early universe is spotty. It's like a spotty baby. It has hot and cold spots. These hot and cold spots are absolutely fundamental. It tells us that when the universe was the human equivalent of 1 day old, it wasn't perfectly uniform. It already had in it the seeds of the galaxies and the other structures that we see in the universe today.
So it turns out to make a universe like the one we see today, all we need is gas, hydrogen gas, and gravity. Now, gravity comes for free in our universe, and it turns out to make stars and galaxies is very easy. You simply take that gas that was formed in the Big Bang and you wait.
As we've seen, the early universe wasn't perfectly uniform. It had hot and cold spots. After about 380,000 years, the super-hot early universe had cooled enough for atoms of hydrogen to form, and this gas gathered in the cool spots. As matter gathers, it produces gravity. More gravity attracts more matter, and so on, until you end up with the stars and the galaxies we see today. But there is another more mysterious ingredient. When we study galaxies closely, it appears that they are spinning too fast to hold themselves together. There doesn't appear to be enough gravity to stop the stars from flying off into space.
Physics tells us there must be some gravity produced by matter that you just don't see. That's what today we call dark matter.
And for the universe to behave as it does, there must be about 5 times more of this invisible dark matter than there is of visible matter.
The dark matter is the circus master. It calls the tune. The dark matter is the force that has sculpted our universe. Without dark matter, there would be no galaxies. Without galaxies, there would be no stars. Without stars, there would be no planets. Without planets, there would be no people. We owe our existence to dark matter. Simple as that. No dark matter, no people.
It's taken around 13 billion years for our visible universe to get to where it is today. But what does the future hold? Until about 10 years ago, cosmologists had 3 theories for what would happen to our universe. 1, that the amount of gravity in the universe would slow its expansion down until it collapsed back in on itself. 2, if there wasn't enough gravity, then the universe would keep slowly expanding forever. And 3, that there would be just the perfect amount of gravity so that the universe grew to a particular size and then stopped. But then astronomers discovered something completely unexpected.
Astronomers have made this amazing discovery. The expansion of the universe is accelerating. Now, how can that be? Astronomers realize there must be something pushing. We don't know what it is, but we know it's there. And this agency that is causing this accelerated expansion, it's called the dark energy.
So it appears that although we've answered a lot of the big questions, we are still left with many more.
We don't know what is the dark matter. We know it's there. We don't know what it is.
What went bang? What happened in the very early stages of our universe? We don't know the answer to that either.
We haven't got the faintest clue as to what our universe is going to be doing billions of years from now. We just don't know because we don't understand the dark energy.
We need help, you know. If there are any scientists out there, young people who want to try and answer these questions, we need help because we don't understand an awful lot about the universe.
There's a lot to play for and lots of exciting new discoveries waiting to be made.